refreshing break from equations, we have to deal now with a couple of inequalities. So 1 is less than or equal to half of x, but if 1 is less than or equal to half of x, then 2 of course would be less than or equal to x, because, well, whatever half of x, whatever condition applies to half of x, whatever number applies to half of x, twice that number must therefore apply to x. So 2 is less than or equal to x. What does that mean on the number line? Well, imagine we've got a nice long neat number line over here. Oh, that's not a nice long neat number line. There we go. That's a wee bit better. Somewhere over here we've got 0. And I'm not going to bother labeling everything here, just the bit that's important to us for the purposes of this question. So we've got 0, we've got a 2. Now, x has to be less than or equal to, so how do we represent that range? Well, we represent it with a dot just above 2. And we fill in the dot to represent that this value of 2 is included in our range of solutions. And we just go ahead and draw array, and you can draw that as long as you like. Typically, it should extend all the way to the number line. You can also just go ahead and put an arrow down. But you know, for the purposes of it looking pretty and complete, let's go ahead all the way over there. And now you get to say that this represents one of the ranges of x. This is one way, rather, to represent the range of x that satisfies 2 is less than or equal to x. Okay. 8 plus 3x is greater than negative 1. What that means, subtract 8 from both sides. 3x is greater than negative 9. But if x is greater than negative 9, for that to happen, x must be greater than negative 3, because anything that's smaller than or equal to negative 3 will give you answers that are smaller than or equal to negative 9. So again, oh, nope, stop that. You stop that. You stop that. You be straight now. Why, you little... Yeep. Okay, better. It's harder than it looks, okay? It's harder than it looks. Put a number line. A 0, somewhere snap in the middle. 1, 2, 3, negative 1, negative 2, negative 3. So x is greater than negative 3, but it can't be equal to negative 3, it just has to be greater than negative 3. So that means you start from here and you just go all the way. You start from here and you go all the way over there. But you don't include negative 3, because when you include negative 3, 8 plus 3x becomes equal to negative 1 and is not greater than negative 1, which is what we're interested in. If 1 is greater than or equal to negative 3x plus 7, then minus 6 is greater than or equal to negative 3x, because we can subtract 7 from both sides of the inequality and still have this side be lesser than the other side, because if this side was bigger before 7 was added to both sides, then even before 7 was added to both sides, this side must have been bigger. Now I can go ahead and divide by negative 3, so I end up with 2 is greater than or equal to x. So that means x has to be less than or equal to 2 for this equation to be satisfied, for this inequality, sorry, to be satisfied. So let's pick a value of x. 0. Well, negative 3 times 0 is 0. 0 plus 7 is 7, which is not less than or equal to 1. 1 is in fact greater than 7, so what went wrong? We figured out this range for values for x, but apparently there are values inside this range that don't satisfy our original inequality. But what went wrong is right here. The error in our best laid plans happened here when we divided by a negative number. Now the reason that messes up all our plans is because, well, consider a number line. You've got 0. We define greater than or lesser than based on whether or not something is to the right or left of its position in the number line. So negative 2 is less than negative 1 on the number line, because negative 2 is here, negative 1 is here, negative 2 is to the left of negative 1. By contrast, 1 is greater than negative 1, because 1 is to the right of negative 1, 2 is to the right of 1, therefore 2 is greater than 1, and so on and so forth. So under these circumstances, when we had negative 6 is greater than or equal to 3x, we had negative 6 somewhere over here being greater than some other number. When you multiply by a negative number, the relationships flip around. So here's an example of what I mean. 1, we've got 1 being less than 3. We've got 1 being very nicely less than 3 over here. This makes sense. 3 things are more than 1 things. But if you go ahead and multiply both of them by negative something, so you map them onto the negative side. Well, let's say by negative 1. So 1 becomes negative 1, negative 3, and 3 becomes negative 3. Then, well, in absolute value, negative 3 is, of course, still bigger than negative 1, because in absolute value, in just magnitude, sheer amount of how far away is this from 0, the sheer distance, here it's 3 units, here it's 1 unit. So the absolute value of this is still greater, but negative 1 is to the left of negative 3. So while 1 is less than 3, negative 1 is greater than negative 3. Negative 1 lies to the right of negative 2 on the number line and is therefore greater. Now that means in an inequality, whenever we multiply or divide by a negative number, whenever we do that, we have to keep in mind that the sign of the inequality is going to flip. Whatever relationship we had between the two numbers before multiplying by a negative number, after we multiply or divide by a negative number, that relationship is going to flip. 1 is less than 3, multiplying by negative 2 or dividing by negative 3 is just going to leave you with, the inverse of the relationship that you had before, which in this case, 2 would have been greater than or equal to x if we didn't flip the sign, but that's not for 2. That's for a negative 2 and negative x. If negative 2 is greater than or equal to negative x, 2 has to be less than or equal to x, because the relationship is reversed whenever we multiply or divide by a negative number. So if 2 is less than or equal to x, then of course means x personally is going to be greater than or equal to negative 2. So where do we have negative 2? Right here. X is allowed to be equal to positive 2. So x is allowed to be equal to positive 2. So if x is allowed to be equal to positive 2, so we can go ahead and fill in this dot to represent that not only are we starting our range at 2, but 2 itself is included in our set of answers. Go the way over there. And that is the range of values for x that we've got going on that will satisfy this equality. Let's pick one. Let's pick 3, for instance. Let's make sure that this, in fact, does work. Negative 3 times 3 is negative 9. Negative 9 plus 7 is negative 2. 1 is, in fact, greater than or equal to negative 2 because negative 2 is over here, 1 is over here. So, yeah, 3 and it looks like all other values over there will, in fact, satisfy this inequality.